Okay, it's already time. I think we should start. Just wait for 2 more minutes, then we'll start. So in the Google chat room, I have posted something about a course like Nurturing Contemporary Research, NCR 01/2021. So those who are enrolled in this course, like CNP, are automatically enrolled in NCR course. So yours, like it's an optional thing, but you are supposed to like present a research paper, like a recent one, and like read it out and like read it and then make a presentation on it and present for like 15 minutes. That's the course is about. So it's an optional for like many of you, but there are some people who are for whom like it's mandatory. So I have posted a schedule list. So if you are like, if you want to present something, then please fill the title up before it's 20th February. So Maruf, are you here? Maruf? Could you please copy and paste the like link here again in chat of Google Meet? Okay. So should we start? Also, if you haven't like joined Google Chat yet, please join. Also, try to collect your copy of Misner, Thorne and Wheeler's gravitation text as soon as possible. So collect this book. If you haven't done already, do it. So not everyone is here yet. The link to the like NCR schedule. Okay, so what I got last time, last day we did a green function procedure and found a solution to a damped driven harmonic oscillator, and it was a general solution to it. Like that's what we got last time. So what was our solution? So yeah, it's a lot of work we did that time. The last class was mathematically pretty intense. Okay, so this was the solution. Hmm?
Yeah.
Okay, so today actually, like after that, we started something else. We started to solve the same system with a very different approach. So that was the direct integral procedure. So that's what we are trying to do. So where is that? Let me check. Oh, here it is. No. It's not. It should be somewhere here. Oh crap. Probably it couldn't save it. No, I don't see it. No. Oh, no. Here it is, right? Yeah, here it is. Yeah. Okay, let's have a review what we were doing last time. So last time we had a differential equation of the form like mx double dot plus bx dot plus k equals kx. Oh, it's not k of x, it's kx. K multiplied by x. I don't think this thing is connected. Yeah, now it works. So it was k multiplied by x, not k of x. So this is what we had. So what we did, we divided the whole equation by m, and we got like d2 over dt squared plus twice gamma d over dt plus omega squared on x equals to f over m. So we said that this part is a differential operator, a second order differential operator, and we were trying to find an inversion to it. So that's what we started. So we started by noticing one thing, that we can split. Someone's trying to join, I believe. No. Oh, okay. Yeah. Okay. So we said that derivative operator, that second order differential operator, this thing can be splitted in two parts, like ddt minus alpha on ddt minus beta on x. So, and to justify that, actually we splitted that thing, like factored out that thing and showed that, okay, this is the case, that this can be factored out in this way. And also we found the values for alpha and beta, right? So what was alpha and what was beta? Do you guys remember? At least I don't. What were those?
Alpha was gamma plus I capital omega. And
okay.
Beta was minus gamma.
Okay. Alpha was what? Say that again.
Minus gamma plus I capital omega.
Plus I big omega, and
yeah.
Beta, yeah. And then negative gamma, negative I big omega, where big omega is defined as square root of small omega square minus gamma square, I believe, right?
Yeah.
Okay, so that was that thing, alpha and beta. So now we already like splitted that thing into first order derivative terms, and we were trying actually to invert one of those. So we considered ddt minus beta on x, this thing as a whole y, this whole part as a y, this part. And then we said like then ddt minus alpha on y is equals to f over m. So we did a trick. We actually found a substitution for ddt minus alpha, and we used that. So what was the substitution? We showed that ddt minus alpha can be written as e to the power alpha df over dt, like ddt minus alpha on e to the power alpha f could be written as e to the power alpha t on multiplied by df over dt. So that's what you showed here, right? You take differentiation and like that rule, and you'll find this. Just do this operation explicitly, you'll find that. So we substituted, instead of like ddt minus alpha, we substituted e to the power alpha t ddt. That's what we substituted over here. Oh, actually, you have to multiply e to the power alpha t inside of it, yeah. Otherwise, it don't work. Like you need this part. Okay, so then that differential equation was converted into this thing, and we had e to the power alpha t that was like just a multiplication of function of t. So we actually took inverse of it and multiplied on the other side, on both sides actually, and this goes out, like goes away, and then we are left with ddt on y e to the power minus alpha t equals to f over m e to the power minus alpha t. So this thing is like a total derivative, total time derivative of something equals to purely function of time. So we can integrate this thing, right?
Yeah.
We can integrate this thing, and we did that. Considering like at like from the limit like 0 to t, where at t equals to 0, we had our velocity like x like position x0 equals to x naught, and x dot at 0 equals to v naught, or actually v we wrote, right? Just v, I believe. So from that we actually found what is y at 0. So the using the relation, and we substituted it back. That's what we did last time, I believe. Yeah. So far we have this thing, y e to the power minus alpha t equals to y at 0 plus 0 integration 0 to t f over m, f of t prime over m e to the power minus alpha t prime dt prime integrated over 0 up to t. 0 up to t. Actually, I noticed like we could do a little bit more general thing than that, actually. So you could actually substitute t naught over there and substitute the limit. That's going to work as well. Also, there is an advantage of t equals to 0, like instead of t equals to 0, we could put like t equals to t naught, because we can always get back our t naught equals to 0 part, and also we could generalize the integral. So I think it's better to switch to the more general one. Like I want to give away this part, like this part. Is that okay with you, then, guys? Hello?
Yeah.
Are you guys okay with that? Okay, integrating instead of like 0 to t, we are doing it t0 t naught to t. I think that's the more general thing to do. So our initial data is like x at t0 naught. Let's say this is big X, and x dot at t0, let's say it. That's easy to write. Okay.
Yeah.
So question is
x minus beta
so
v.
what was y? What's the definition of y?
Ddt minus beta into
D on x.
On x.
So that would give us x dot minus beta x. So y at t naught would give us x dot at t naught minus beta x at t naught, right?
V, yes, minus beta.
Yeah, so v minus beta x over that limit. So we get y e to the power minus alpha t. If we integrate this thing over t naught to t, we get like this, right? So you could write this thing as like primed, but it's not necessary here. So, and then if you integrate this thing, you get t naught to t integrated over f of t over m e to the power minus alpha t. Actually, let's change the variable because it would confuse us later. So this is what we got, right?
Yeah.
Is that correct? I missed something. No, I think it's okay, right? So now what we are going to do, we are going to substitute the limit. So if you substitute the upper limit, it gives you y at t e to the power negative alpha t. And if you substitute the lower limit, it gives you y at t0, t naught, e to the power minus alpha t naught. Right?
Yeah.
Yeah.
So this thing is nothing but disintegration. And now we can substitute, instead of y at t0, we can substitute this stuff like v minus beta x, right? Instead of this thing.
Yeah.
So we get y at t e to the power minus alpha t, and take this part on the other side. So you get that equals to v minus beta bx multiplied by e to the power minus alpha t naught. Then
This integration.
yeah, and then that integration 0 to f at t prime over m e to the power minus alpha t prime dt prime. That's what we get. So you guys are following so far?
Yeah.
This is what we got last time. We didn't finish this thing, right?
Yeah.
So now we are going to do going to perform the integration again. We have to integrate again because we have our y of t, and that y of t is basically a derivative of x. So let's substitute that. Sometimes this software behaves really weirdly. Okay. So now take this line y at t e to the power negative alpha t, and then this. And what we are going to do, we are going to take this exponential on the other side and just write y of t equals to v minus beta x, beta big X, e to the power, what do we get? Negative alpha multiplied by t minus t naught. Is that correct? Or I made a mistake in the sign?
I think it should be positive alpha.
Yeah, it should be plus alpha. Yeah, I'm bad at algebra, so pardon my mistakes. Okay, so then e to the power alpha t f at t prime over m e to the power negative alpha t prime dt prime. Right? So far, so good.
Yeah.
Now we substitute our y of t. What was y of t? It was ddt minus beta on x of t, right?
Yeah.
Equals to this blah blah blah. Let's simplify this thing first. So we are going to do the same trick again. ddt minus beta on e to the power negative beta.
I think we can just follow the last pattern we got
Yeah,
from
we can do that as well. I'm just trying to do a little bit more explicit. That's it. Sometimes, like when we jump some steps, everyone may not follow. So that's why I'm a little bit careful about doing this. Okay.
okay.
So we have like DDT minus beta operating on e to the power beta t, and then x at t e to the power negative beta t, right? So this is again our that f that we used in our expression, right? Like we had a formula. So what we can substitute for that now? I think we can write e to the power beta t ddt on f, which is uh, x at t e to the power minus beta t. Is that correct?
Yeah.
Or let's check what we did last time, what we had last time. So we had this formula. So ddt minus alpha e to the power alpha f alpha t on multiplied by f, that should give us e to the power alpha t df over dt. So we have that same pattern, I believe. Yeah, the positive one comes out of the integration, not the negative one. Okay, so this is what we have. So we substitute that thing for y of t, and we get e to the power beta t ddt on x of t e to the power negative beta t equals to v minus beta big X, big V minus beta big X e to the power alpha t minus t naught. And then plus, let's see, what was that? E to the power alpha t integration t0 up to t f at t prime over m e to the power negative alpha t prime dt prime, right? So what we
Yeah.
are going to do, we are going to invert this thing, like take this e to the power on the other side. So we get ddt x of t e to the power negative beta t equals to, what do we get? So we have a whole like e to the power negative beta t multiplied by the whole thing, right? Actually, we could take that thing here and
You can consider this whole thing as some other
no no no
later.
no 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 no, no. Yeah, we can do that. We can do that definitely for momentarily, right? For a moment, like consider this thing something. Yeah, we can do that. We can do that. It's a some function of basically t, a purely function of time. So we can write it as like big G of t, or no, that's the green function. So h of t. Let's say this is h of t, and we just write it as h of t. That whole thing as h of t. Is that okay? We'll substitute that later.
Yeah.
So now we perform the integration again, and we get x at t e to the power negative beta t, and the limit would be t0 to t, t0 to t equals to, now you have to integrate this thing again. So e to the power negative beta t double prime h of t double prime integration t0 to t dt double prime. Is that okay?
Yeah.
So now what we can do, we can substitute this thing. So we get x of t e to the power negative beta t minus x at t0 e to the power negative beta t. t0 equals to integration t0 to t e to the power negative beta t double prime h at t double prime dt prime double prime. So what is x at t0? What is x at t0?
Capital X.
Capital X.
From the initial time.
Yes, this is big X, right?
Yeah, big X.
You can write like that. We're almost done actually. So x of t, now we have a solution for that. May not be in the most convenient form, but that's a solution already. So x of t equals to big X e to the power beta t minus t naught plus e to the power beta t integration t0 up to t e to the power minus beta t double prime h at t double prime dt double prime. Right? Now it's time to substitute h of t double prime back in the expression. So what was our h? It was a long thing, right? So please copy this thing and tell me, like I cannot remember this thing, this whole thing together. So it gives us now we need to substitute h of t double prime. What's that? It's big V minus beta big X then e to the power alpha e to the power alpha. Instead of t minus t prime, we need to write t double prime minus t0. I mean, it was t minus t0. Instead of that, we have to write t double prime minus t0 because it's not h of t, it's h of t double prime. So we were careful about the integral variable. That's it. So and then e to the power alpha t. So plus e to the power alpha t double prime integration t0 to t double prime f at t prime over m e to the power negative alpha t prime e to the power negative alpha t prime dt prime. This one part, and then now we have our h in total, then there should be a t double prime as well. Oops. dt double prime as well. Yeah. So this is the full result. I think it's hard to see. Let's make it smaller. Yeah, this is the result. Right? So we need to perform the integration now. So for the first term, it's just big X equals to big X multiplied by e to the power beta t minus t naught. That's all. And for the next one, like for this part, actually we need to perform the integration, right?
Yeah.
So v minus beta x, this is a constant thing, so we can take this thing out of the integration. So we get v minus beta x e to the power beta t, and then we are left with integration t0 up to t e to the power negative beta t double prime e to the power alpha t double prime minus t0 dt double prime. This is one part, I think.
It is our minus alpha t naught is also a constant. So
Yeah, we can take that that thing out of the integration as well. Yeah, e to the power negative t naught
alpha t naught.
alpha t naught is also a constant. Yeah, we can take that thing out of the integration as well. So if we do that, it is e to the power negative alpha t naught. So we do not need to write this part anymore.
It will be then simply alpha minus beta t double prime.
Yeah.
Okay, we'll do that later in the next line. And then plus. So we have a double integration right now. That's a problematic thing. So let's start by writing down everything. So e to the power beta t is the first thing. Then we have an integration e to the power t0 up to t e to the power negative beta t double prime, then multiplied by e to the power alpha t double prime, then t0 up to t double prime if at t prime over m e to the power negative alpha t prime dt prime, and then again dt prime, dt double prime.
Yeah.
So this is a long thing, but I think we can integrate that. So let's do bit by bit. So for the first part, we get x e to the power beta t minus t0, and then plus we have, oh, what do we get if we integrate this thing?
If alpha not is equal to beta, then
No, there isn't any equality, so we have to do for all of this. So yeah, this part, now this is integration. So what's the integration? This is alpha minus beta, like e to the power alpha minus beta t double prime, right? So if you integrate that thing, it gives you 1 over alpha minus beta e to the power alpha minus beta t double prime, but the limit would be t naught to t, right?
Yes.
if alpha is equal to beta, then the integration would be only t
alpha
minus
is
t
not
naught.
beta. Not alpha. Alpha is not equals to beta.
Well, it could be the imaginary part was 0.
Yes, that's correct. But in general, it's not. So we have to be careful about that.
Okay.
So okay, then this double integration part. So we have plus. Can you pull out anything out of those integrations? Do you see anything that can be taken out of the integration?
One by m.
No, you don't see it, right? But we can do one thing. We can take this thing inside of this integration without any hurdle, right? Because here the integral variable is t double prime, like for this integration, and this is a function of t. So we can, without any hurdle, we can take this thing inside of this integration. Also, this e to the power alpha t double prime, we can take this thing inside of this integration because this integration performs on t single prime, right? So we can write integration t0 up to t e to the power beta. Actually, I want to write the opposite way. No, it's fine. T minus t double prime is fine. Okay, this thing, and then t0 up to t double prime e to the power alpha t double prime minus t prime. F at t prime over m, first integration is dt prime and then dt double prime. We can do that, right?
Yeah.
Okay, okay. So now we can substitute this limit and say things, but first we perform this integration. First we perform this integration. So what else can be done? What else can be like taken out or inside of this integration? We cannot do anything else, right? Like so far, this is what we have. So now we perform an integration by parts. Perform an integration by parts.
Mass cannot be taken out.
Yeah, that can be taken out of this integration only. Yeah,
Okay.
that can be. Yeah, you can do that. Instead of write it over there, we can write it over here. Okay, I think e to the power beta t won't help that much. Like, do not take this thing on inside. Like, just do the other one. Okay. Okay. Let's do it explicitly. Like, so we have 1 over m e to the power beta t. Like, it's a side calculation. So we have this thing. It's t prime, dt prime.
I think we can take the whole everything inside the even the second integration and try to change the reason of integration. You know, like
Yeah,
we
we
did
can
in the previous time, so that we can take the ft prime out and then the whole integration will be able to perform.
yeah, change the integration variable. That's one procedure. Yeah,
I mean,
that can,
just change the region type. Type 1,
yeah,
type 2.
like upper and lower limit. Like that's what's gonna get changed. So I think the way, like I have a note over here. So the way it is done over here is like just doing integration by parts instead of
Oh,
changing
okay.
the limit.
Okay.
So I think it's better to follow this. Otherwise, like I do not know, I could screw up something and may not get out of it. Okay, so we can write it like this. 1 over m. It's almost same thing. But then did I made a mistake? I think. Yeah. It was like alpha t double prime, right? Like, yeah, it was alpha t double prime. So yeah. So now what we can do, like we actually take this thing inside, but not this thing inside. So if you take this thing inside, then it gives you like actually you can take this other thing inside as well, because this thing is integrating over t prime and this thing is integrating over, like this is a function of t double prime, so you can take inside of the integration. So you get t0 to t, then t0 to t double prime e to the power alpha minus beta t double prime f at t prime e to the power minus alpha t prime dt prime dt double prime, right? We can do that.
Yeah.
Okay. So now consider this thing, like we are trying to perform an integration by parts. So consider this thing to be our du, like d of whole something, some function. We just need to find that. And consider this thing as your v. Oh, actually we use that v, so yeah, let's use a smaller one. So du and this v, right? So if we consider that, we know that d of uv equals to vdu, vdu minus u dv, right?
Shouldn't it be plus?
Oh, yeah, that should be plus.
Yeah.
So now our VDU can be written as d of uv. Actually, I should distinguish it more. udv, right?
Yeah.
Okay, so all we need, like we need to construct this the other part, right? So to construct that part, like to construct our v and u explicitly, we just need to integrate the other thing. So as we have our du equals to this whole thing, ft prime e to the power negative alpha t prime dt prime. So what is our u? What would be our u? Like u would be integration f at t prime e to the power negative alpha t prime dt prime, right? And if the limit is like t0 to t double prime, I think then if we call it u as this u, then du would be like this this part, right? No, that's a mistake in the prime, like inside of, like I want something just single prime. So what we would do, let's change this thing. F of t double prime, so double prime, and then this thing is single prime. Yeah, I think this thing works, right? So du would be the inside of that this small part, right? Do you guys agree, or I need to explain it? Hello.
Yeah.
So I am changing the integral variable like prime or unprime, because end of the day our du has to be a function of t prime, not t double prime. So if our integral limit is t naught to t double prime, then if you take d on that, that is a function of t double prime, not t single prime. So that's what we changed actually here. Du is a function of t prime. Du is a function of t prime, not t double prime. And then what about v? V is just the other part, like this thing. So v at t double prime is nothing but e to the power alpha minus beta t double prime, right?
Yeah.
So what would be your dv? It would be alpha minus beta e to the power alpha minus beta t double prime.
Alpha minus beta into v.
Yeah, you can say that as well. Alpha minus beta into v. Actually,
dt prime. vdt.
vdt double prime. Yeah. So this is what we have. So remember, we have our like inside of this integration, like we want to perform or like integrate this thing by parts, and then finally we would need our dv and the whole u. So let's do the integration by parts first, then we'll talk about it. So we have our v du, so we substitute that thing, 1 over m e to the power beta t integration t0 up to t0 up to t double prime. Then we have our v as e to the power alpha minus beta t double prime, and du is this other part.
Yeah.
So how can we write it in terms of the other thing like this? So I'll just write it casually, then substitute. So it would be like duv minus u dv, and then dt double prime. Did I make a mistake in the integral variables?
No.
I think I did, because my dv is a function of t double prime, like it has a t double prime inside of it. Oh, actually, was it t double prime or single prime? It was double prime, right? This thing was t double prime.
Which one you were talking about?
This thing. This thing was t double prime or t single prime.
Okay.
Yeah, I think it was t double prime. Yeah, because we had this e to the power beta t double prime e to the power alpha. So that's the thing that we have. So that was t double prime. So that's okay. That's okay. Oh, actually, we are trying to change the order of the integration as well. So okay. But du part is just a single variable. That shouldn't be. Like, we do not have any dt double prime over there, right? That shouldn't be the case. I simply oversimplified this thing. Just give me a moment. Just give me a moment. Oh, okay. I see it. I see what I want to do. Okay. Okay, I have to do a little bit more. That actually, all I want to do is like, see this integration, like t0 up to t double prime. This integration is this, right? Like integration over like single prime variable. But when you like perform this integration, this whole thing, like integration, this whole thing, it becomes a function of t double prime. So actually, instead of doing that, what I wanted to do actually is this. So I wanted to write t0 up to t e to the power alpha minus beta t double prime, t0 up to t double prime, f at t prime, e to the power minus alpha t prime, dt prime. So this is one thing, and then dt double prime. This is what I wanted to do. So if I consider this thing as my function, this thing as my u, and this part, like this and that part, it considers my v, dv. So then it works. So let's write it down like that. So 1 over m e to the power beta t, t0 up to t. Then first write u. So this is my u is t0 up to t double prime, f at t prime, e to the power negative alpha t prime, dt prime. This is one part, and then e to the power alpha minus beta t double prime, dt double prime. So this is my dv. So now we can perform integration by parts for this one, right? So we can do the previous way we wanted to do, like, or we can actually do a more trivial way, like take this thing and take derivative of the other thing, like that. We can do that as well. So let's do what we are trying to do. So we have our u dv term, right? We have our u dv term. So what is u dv? U dv is ddt duv minus v du, right? So we can write 1 over m e to the power beta t integration t0 up to t, and then we need to write the other thing. So d of uv is nothing but this thing, t0 up to t double prime, f at t prime, e to the power negative alpha t prime, dt prime. This is our u. Then v we had our dv. We need to integrate that thing to find our v. So our dv, we had this thing like e to the power alpha minus beta t double prime dt double prime. So what would be our v? That's the question actually I should ask. What's our v?
1 minus 1 by alpha minus beta into
1 over alpha minus beta e to the power
alpha minus beta.
Beta t double prime, right?
Yeah.
So this is what we want to write. So 1 over alpha minus beta e to the power alpha minus beta t double prime. Okay, so this is one part, d of something, and then minus v du. So minus, what is our v? V is nothing but 1 over alpha minus beta e to the power alpha minus beta t double prime, and then du. What is du now? What is du now? What was our u, and u is this?
du is simply f of t to the power minus alpha t prime.
No, be careful. So this was our u. What is du?
F of t prime.
F of t double prime.
F of t double prime. That's the point. F of t double prime, not single prime, because when you perform this integration, this whole thing is a function of t double prime. So differential of that thing would be a function of t double prime as well. So that's what we have to be careful about. So we need to write f of t double prime e to the power negative alpha t double prime, then dt double prime. So d of uv minus vdu, that's what we had. Now finally, yeah, I think that's all right. Actually, we should close the bracket here. That's all. Do you guys agree? Up to this point, I think
Yeah.
we are almost done. We are almost done.
Yeah.
So now what we can actually perform, we need not to perform the last integration. We just need to simplify this thing. That's all. We just need to simplify this thing. Also, we have our d of some integral, so we can actually find that something that like d of whole thing, so we can actually perform this outer integral. So let's do that. So 1 over m e to the power beta t, then we have integration t0 up to t d of some whole thing, integration t0 up to t d of some whole thing. What should be the result? D of something. Integration d of something. That's something, right?
Yeah.
Just the function.
Yeah, that's something, but it needs to be evaluated at lower limit to upper limit, that is t0 up to t. So we have that something that is t0 up to t double prime if at t double prime, oops, no. T prime, yeah, it's a single prime, right? E to the power negative alpha t prime dt prime, it's a function of double prime, actually t double prime, the whole thing. So negative alpha minus beta e to the power alpha minus beta t double prime. This whole thing needs to be evaluated at t double prime equals to t0 up to t double prime equals to t. That's what we need to do.
Yeah, and t double prime is equal to t0 gives 0.
Yes.
No idea is calculated.
Yeah, so nothing is required to calculate, right? So like lower limit need not to be calculated. So the upper limit works only. So what should be the result actually then? So basically this is nothing but when you substitute upper limit, it just t double prime becomes t single prime.
T naught to the integration is t naught to t just, I think.
Yeah, this integration is t naught to t. Like if you just substitute upper limit t naught to t, and then like this t double prime becomes t as well. And for the lower limit, this thing becomes 0. You can see, right? Because it becomes like integration t0 up to t0, which is 0. It doesn't matter what you multiply with 0. So it's 0 anyway. So if you substitute these two limit, we can actually do a little bit shortcut here. So that becomes this. That becomes this also this. Do you guys agree?
Yeah.
And then we have negative. We have actually some real integration over here. So negative 1 over alpha minus beta can be taken out of the integration, and then we are left with integration t0 up to t e to the power. Look, in this integration, we do not have any double prime. We do not have any single prime. So we can actually, without any ambiguity, change the dummy integration to single prime, right?
Yeah. Also, e to the power minus alpha t prime actually vanishes.
Mm-hmm. Where do we have alpha t prime? Oh, over there. Okay, okay, okay. Yeah, that part vanishes. Okay, so it just gives us e to the power negative beta t single prime. If at t single prime, it then dt single prime. Whew, boy, it's
Oh,
a
there's
long
a
thing.
similarity in this integration, just alpha and beta.
Yes, when alpha equals to beta, that's a singular thing, right? Hello.
Yeah.
So can we like simplify this integration a little bit further? So can we factor out from anything from these two terms?
Alpha minus beta.
And then I think this integration is also same thing that appears, right? So we can actually factor 1 over m e to the power beta t, then 1 over alpha minus beta, that's also same thing, then integration t0 up to t.
E to the power minus alpha plus beta. Minus alpha
okay.
plus
So
beta.
minus alpha plus beta.
No.
I need to take this whole.
E to the power alpha t prime plus e to the power minus bt prime.
E to the power minus alpha. No. You cannot do that.
Oh no. No. Yes. There is
Actually, let me. Let's make it not that much simple, but a little bit simple. So. So they have f of t prime, and then these two things are different. So what am I going to do? As I said, I'm really bad at the algebra.
I think we can multiply e to the power beta t inside, and so the ultimate result is very nice, I think. Just multiply it to the power beta t, then the first term only to the power alpha t remains, and in the second term only to the power beta t.
Oh, you're saying like multiply this thing e to the by e to the power alpha t.
There is e to the power beta t is in the outside.